So I'm gonna start the manage container log file scenario. Starting the scenario. Start. There will be three steps. First one is Docker log. So in the background there's an instance of Redis running with the server name Redis server. So using the Docker client, we can access the standard routes and standard data output using Docker logs Redis server. So to do that, so I'm just going to run this. As you can see, it's output the versions and the logs which contain every details about it. So I'm going to move to the second step, which is system log. So this is the syslog driver will write all the containers logs to certain syslog on the host. So syslog is a widely used standard for messaging logging. So it permits separation of software that generates messages and the systems that stores them. So software that reports and analyzes them. And the command will be redirect the Redis logger to syslog. So this will be the command, and this will be output and automatically redirect to the syslog. So I'm going to move to the third step. So disable logging. So when the container is launched, simply set a log driver to none. So output will be a log. So to do that, I'm just going to run this command by clicking this button. So now it's changed so that no output will be log. So that's all for the manage log files in Docker. So and there will be inspect commands used to verify the logging configurations for particular containers. The command below will output the log config section for each of the containers. So we did in step one. These steps the server will create. So this for the step two server creation, and in this step actually the server created. So yeah, so that's all for the manage log files. We'll be moving to the next scenario, which is ensuring container uptime with restart policy. So I'm going to start scenario again. So there will be three steps. So one is the stop and fold. So we created special container which outputs a message and then exists with code one to simulate the crash. So to do that, so I'm going to run this command clicking by this icon. So as you can see, these files has been already exist, but this it's finished, and you can see a list of the containers including stop ones in the graphs. You can see it here. Images, container IDs, command creators, and status. So this will restart 24. The color restart default, and the name it BBC. So I'm moving to the second step, which is restart on phone. So depending on scenario, restarting a failed process might correct the problem. So Docker can automatically retry to launch the Docker for a specific number of times before it stops. Right. So as example, I will run this code to show you that. So by clicking this, I'm just running the code here. So as you can see from the logs, it was launched on three. Actually, one is there's one container ID. So I'll just restart it again. Moving to the third step. So finally Docker can always restart. So in these steps, the final step, the final Docker can always restart a failed container. In this case, Docker will keep trying to until container is explicitly told to stop. So example, just going to run this command to show you that. So this will prompt to uh, to the status to always restart. So yes, so as you can view the restart attempt via the log, so then you can check from this command. As you can see, this command, just run it from here, and here are the. So that's all for the shooting up time scenario, and now moving to the next scenario, which is adding Docker metadata and labels. So in this scenario, there will be 5 steps. So the first one is Docker containers. So we have to on the Docker first. Oh, document. Okay, then single label. Let to add the single label, as you can see the example below. So I'm just trying this for the internet files. If you're adding multiple labels, then this can come from external files. So the file needs to have a label on each line, and then this will be attached to the running container. So as you can see, I'm just running this code command. So you can see the labels. So and this option will create a label for each line in the file. So I'm running this again this command to show you that. So I'm moving to the second step, which is Docker images. So single label, multiple labels, and all are there, as you can see. To one. So in steps 3, the labels and metadata are only useful if you can view query them later. So the first approach we to write to view them all labels for a particular container or images using the inspect command. So the containers, by providing running containers frontend name or hash ID, you can query all of its metadata by using this command. As you can see, just click this icon to run the command. So we generate these files, so you can see the metadata. So from this command, you can see the labels. Yeah, yes. Actually, I did click the button for 2 times, so twice actually. So the images, inspecting images work in some same way. However, the JSON format is slightly differently with container config instead of config. So to do that, just going to run this command here. As you can see, the command is saved here. So the labels will remain even if the images has been untagged, and making it easier to clean up all the images and containers. So moving to the fourth step, so query by label. So while inspecting individual containers and images provide you with more content. So the product running potentially thousands of containers, it's useful to limit the responses to the container you are interested in. So filtering containers, as you can see in the Docker ps command, and using this command, you can see query below will return. So this is the query, and it return all the containers which have a user label key with the values category. So filtering images, as we can use this command to filter the images, and move to the fifth steps, the daemon labels. So in the daemon labels are not only apply to images and containers, but also Docker daemon itself. So when you launch an instance of a daemon, you can assign it labels to help identify how it should be used. For example, if it is a development or production server, or if it is a more suited to particular roles such running databases. So we'll explore more about customizing Docker's configuration and how labels are used to future scenarios. So, but as task, sorry, the syntax is below, so you can use this command. I don't think this is gonna work, but yeah, it's not gonna. So that's all for the scenario, which is called Docker metadata and labels. And now moving to the next scenario, which is load balancing containers. So in this module, in this scenario, I'm going to start the scenario, and there will be 4 steps. And the step 1 is Nginx proxy. So In this scenario, we want to have an engine service running which can dynamically discover and update its load balance configuration when new containers are loaded. So thankfully, this has already been created and it's called Nginx. So Nginx accept HTTP requests and proxies the request to the appropriate container based on the request hostname. So this is transparent to the user. It happens without any additional performance overhead. So the task command below to launch Nginx proxy is here. So just click that code and oh, it's executing. Yes, I just checking. Sorry. So can make a request by using this command in here. If there is no containers, it will return the 503 error. So we have container, so we are not returning the 503 error. So moving to the second step, single host, the single containers. As you can see, the for Nginx proxy to start sending requests to container, you need to specify the virtual host environment variable. So the variable defines the domain where request will come from should be handled by the container. So from this command, we can first measure our default host to it to be accept our request. Then for testing purposes, we can use this command to takes a few seconds for engines to reload. But if we execute this request to our proxy using this command, the request will be handled by our container. So moving to the next step, which is step 3, cluster. So we now have successfully created a container to handle our HTTP request. So if we launch a second container with the same virtual host, then Nginx proxy will configure the system in a round robin, so load balancing scenario. So this means that the first request will go to one container, the second request to second container, and then repeat in a circle. So there is no limit to the number of nodes you can have running. So this task launch second container using the same command as we go from we are launching second container using this command. I just click here to run this code, and the testing purposes we are using this command to execute the request to the proxy. So that is also here as you can see. So moving to the final, which means the fourth step, so generator Nginx configuration. So while Nginx proxy automatically creates and configures Nginx for us, if you are interested in what the final configuration looks like, then you can output the complete config file with the docx as shown below. So in this command, as you can see, you can see the docx the config file, and in additional information about when it reloads configuration can be found in the logs using the command which is docker logs nginx. So as you can see, sorry, yes, this is the log. I accidentally clicked it for 2 times, but same thing. Yes, this will be the output of the log file. So that's it for the load balancing containers.